can see. All right, so I'm Saba. I'm a Principal Standardization Specialist at Nokia, and I am also the chair of the RTC sub-working group in 3GPP-SA4. And Jordi mentioned that it would be nice to look at some of the real-time communication related work that we have been doing in release 19, something that we haven't been we don't have reference implementations in 5G MAG as of yet. So I've prepared some slides that cover two of these. I understand Thomas was going to cover also the avatar aspects, which are also related to this IMS data channel work that we will be talking a bit about in this first slide set. So I want to ask, do you see the slides? All right. All right, so I'll start with talking about split rendering over IMS. So we started this work during release 19, and we created this spec 26567. And the idea is to enable split rendering over the IMS data channel. And this provides an interoptimal standard that service providers can use for providing split rendering to IMS DC apps. It also reuses existing multimedia telephony framework, which is the MTSI framework, if people on the call are familiar with that, which is the 26114 specification. And then, of course, it leverages the IMS data channel. So I'll be talking a bit about what the IMS data channel is. I wasn't sure if everyone would be familiar with that. And then I would also talk about how split rendering is enabled as part of the specifications, and then what features are available as of release 19. So yeah, so this is the IMS data channel, a diagram that maybe looks a little bit more complicated than it needs to be at first, but the IMS is the IP multimedia subsystem, which is used for instance, the call apps that we have on phones. So what the IMS data channel brings to this existing native apps for calling that you have is a web RTC data channel kind of functionality. And this is a channel in addition to what you have. So we have the IMS audio channel for voice, and then you have the IMS video channel for instance, if you want to upgrade the voice to video communication, and then you have an IMS data channel on top of that. And what the IMS data channel is typically used for is that, for instance, if you have a voice call and you want to upgrade it, you can upgrade that call with what is called an IMS bootstrap data channel. And over that, you can download an app directly from what you see here, the DC app repository. And that app is then going to be delivered directly to your UE, and then it can run as part of the, without downloading from the App Store, for instance, it can run on your phone. And then over the IMS data channel, you can send additional metadata and additional components that, for instance, you can have a DC application server, which is run by your MNO, or it is run by a third-party server that provides some functionality as part of this app. And then on the media path, we have within the IMS, so this is still your mobile network where you would have a media function, and this can provide, it can act as a proxy for your app server metadata, but it can also provide additional media processing for media that passes through it. So yeah, so this is what the IMS DC does, and this kind of opens up space for new use cases and new services that mobile network operators can provide to their subscribers. So what we did in release 19 was to specify how to do split rendering over IMS DC, and for that this is the architecture. And this is your UE. And on this mobile, you have what is called an SRDC MTSI client. So the DC MTSI client is just basically a client that has multimedia telephony capability over IMS, but also has data channel capability. And the SRDC MTSI client is one such DC MTSI client that can enable split rendering. So you have the UE over here, and over here you have the IMS that takes care of, for instance, so this is the control plane, and it, for instance, takes care of the charging and the initial SIP signaling, and for providing you the appropriate resources for establishing the data channel. And over here you have this DC application server and the DC application repository from where you can download the app and then run the app for whatever reason. So for split rendering in this case. So you can see over here that the media passes once the app is running. The media passes over these three components that are shown in yellow. Then I go ahead and so that's a bit step by step about what happens. So you set up, this would be a SIP call that you set up, and then you set up a Bootstrap data channel, which is not shown here, but once you have the Bootstrap data channel, you can download the app. Then for if you want to use split rendering, you would request a data channel, and this is different from the data channel that you use for downloading the app. So this is an application data channel because this is the one that you use to send application-specific data. For instance, for split rendering, you might use it to send pose. And so you set up, you request this data channel for split rendering, and then you can send pose or metadata over this split rendering data channel, and this will go to your media function, which will then process for instance, a 3D scene and provide split rendered media over RTP. So the downloaded media that you would have on the SRTC MTSI client would be delivered over the RTP audio and video communication. So your data channel, in fact, is only used for sending your pose metadata and also, or for instance, your action metadata, and then it's also, for instance, used for setting up the split rendering session. Okay, so the features in release 19 include you can send your pose or action metadata, like we talked, which is compatible with standard XR frameworks like OpenXR and WebXR. These are also in line with what we have in 26565, which is the split rendering over WebRTC that was defined during release 18. And then you have UE, which has audio video capabilities that are conformant with what we already have in 26114, so your MTSI clients. And also in 26119, which has the media capabilities for AR devices that were also defined during release 18. So we don't add any new media capabilities to the device. Then we have features for adaptive split rendering, which allows more flexibility to decide which object is rendered locally and which object is rendered remotely. This can be used, for instance, to reduce the battery consumption on the device, or maybe used for cases where you have some interactive objects that that are better rendered on the device because of delay. Then within these, there are two main features, although this is something, so adaptive split rendering, as far as I understand, is something you can you can leave to implementations, but we have this seamless adaptation based adaptive split rendering, where you can use the object's proximity to the user to dynamically decide where an object should be rendered. So it could be locally or remotely, depending on if the object is closer to the user. And then we have also defined this processing delay-based adaptation, where if the network notices that the split rendering process is taking too long and your motion to photon to render latency is high, so you can improve that, for instance, by reducing the level of detail that you're using for rendering your 3D scene, so that the overall experience remains unaffected. Well, at least you don't induce too much latency into it. Then we also have this on-demand asset delivery or lazy loading. So you download the assets as and when they are needed, and you don't have to download the entire scene. And then we have some eye and gaze-based optimizations also done during release 19, yes. And wait, hold on. So this is all I have on SR AMS. I stop here if there are any comments.